Please open in your learning workbook to page 178 and read along as we learn together. Evaluate the exponential function base e. A symbol that always represents the same value is called a mathematical constant. The most famous mathematical constant is probably pi. Today, we learn a new mathematical constant called e. Like pi, e is a symbol that always represents the same value. E equals 2.718281828459045, etc. Let's read this text box, which gives us some information about math history. Where did e come from? Consider the expression 1 plus 1 over x, all in parentheses, raised to the x power. The value of this expression, for increasingly large values of x, approaches the value 2.718281828459045, etc., which mathematicians named e. The value e is useful in many different fields of interest, including mathematics, economics, chemistry, biology, physiology, and many, many more. Let's look at an example of a problem involving e. Example 3. Graphing f of x equals e to the x power. Graph the function. All right, so what we're going to do here is we're going to replace x with various values, place those in our calculator to get decimal approximations, and then plot those points. All right, let's start out with -3. So we're going to put x equals -3 into our equation, and we're going to use our calculators to evaluate e to the -3 power. All right, so the first thing we need to do is to figure out where on our calculators is e. All right, well, e is right here in our calculator above a button that is labeled ln. So if you want to use e in your calculator, the first thing you want to do is hit the shift key, the green shift key. So we'll hit that. And then after that, you want to hit the ln button, and that's going to give us e. All right, let's hit the ln button. All right, so there we go. So you can see now on the screen it says e, and there's an exponent flashing, and we can put whatever exponent we want in there. And so we're going to put in the value -3. Now remember, negative is this button down here versus subtraction, which is this button over here. It's important to know the difference between negative and subtraction. All right, so let's hit -3, enter. And we see the value of e to the -3. It's 0.049787068, etc. And if you round that to 3 decimal places, you get 0.050. All right, so that brings us back to the learning workbook. When x equals -3, f of x, or y, is 0.050. Repeating this process for the other values of x, we get the other values of y, and we can use those values to create the graph of e to the x. Okay, let's plot these points. So 0, 1, which we've seen on every exponential graph that we've created so far. 1, comma, e, in other words, 1, comma, 2.718281828459045, etc. So just a little bit higher than 2.7 is where we're going to put that y value. 2, comma, 7.389, so that would be up here. And 3, comma, 20.02086 does not fit in the graph. That would be way, way, way up here. All right, and then we connect all those dots together, we get the graph of e to the x. Does this graph have a horizontal asymptote? The answer is yes. The graph, the blue curve, is approaching the x-axis. It will never reach the x-axis. It forever approaches but never reaches the x-axis. So the x-axis is our horizontal asymptote for this particular graph.